because I want to bridge a gap between the standard normal, the general normal, make sure we can get comfortable going back and forth between those two, so basically making these moves here. And then we're going to explore one great application of the normal distribution. That's what we're going to kind of wrap up the class with, is that one great application. We'll start it today, probably wrap it up on Monday, and that way we can take Wednesday of next week, just be a big old review day for your last exam, which is not comprehensive, remember that. It's not a cumulative final, it's just the last 3 homework assignments. So binomial, normal, and then also what's called the central limit theorem, which you won't find up here, but it's a way of having this bad boy pop out when you least expect it, which is really bitchin' actually. It's kind of a nice result that is kind of surprising, I think. So we'll explore that starting today and wrapping up into Monday of next week, and then we'll spend, like I said, Wednesday of next week kind of exploring all those and kind of going over. Yeah, Jade?
There's like a take-home...
There is, and I'll have it posted over the weekend. Probably on Friday, I'll have it up Friday, because your take-home for the exam 3 is going to be due the same day exam 3 is, which is unusual. Usually it's due a week after, but I can't do that because you'll be gone. So I'll make sure you have enough time
We
to...
do have it, because I thought that maybe we don't have it.
No, you will. If you look at the schedule page, it says take-home portion also. This isn't hyperlinked yet, because I haven't written it yet. I mean, the project, I just had that idea. I have to kind of put that together. So we'll get it up soon. Yeah, Trev.
Where are finals? When's the last one?
I don't know. Look on the schedule page. It's on there for you. I can't remember anything, brother. So I put everything online. Cool? All right, let's shut this bad boy down and go over here. So what I want to do is, I want to revisit, actually, we don't need that right now. I want to revisit IQ scores. I know it's been a week, and I hate that it's been a week, but at the same time, it's a well-needed break, I'm sure, for you guys. I want to go back to IQ scores, and I want to make sure we can go back and forth between that wonderful little program we were playing with in class last time and when you can't directly use the program. So back to IQ scores, in case you don't have these handy in your notes. IQ scores have an average score. Remember what that average score was?
100.
It's 100. That means your head is as old as your body is. Basically, is what that means. Your mental age and your chronological age match. So whatever it is divided by the same thing as 1 times 100 is 100. So you're 100. If you think it was 100%, that's fine. It's just 100. It's an average IQ. And there's a plus or minus around that. There's a plus or minus around that, and that's defined to be, you remember? 15. Exactly. And that makes all the difference, right? That really does make it. We'll see how adjusting that can change percentages soon enough when we play with the human pregnancy length examples. Okay, so last time we played with an example, a forward example. We did a couple forward examples, actually. We decided what percentage of people were morons, idiots, dull, normal. Remember all those wonderful ranges? And those were all forward type problems. I want to do a backwards type problem now. I want to do a backwards type problem. So there's a group called Mensa. And I forget what it stands for. It's something.
Is it abbreviation?
I think so. I think so. I don't know. Maybe it's not. Doesn't matter anyway. But the requirement of getting into Mensa is, well, there's a couple different requirements. One of them, though, they require, in order to get into this club, and I'm not even sure what the club does. I think it's just like, well, you'll see in a minute what you think they do. They require the top 2% of IQs. In order for you to get into Mensa, you have to have an IQ that's in the top 2% of the population. That's the requirement for being in Mensa.
Excuse me, Mensa is, what is it?
I don't know. It's some kind of organization for
organization.
of smarty pants.
Okay.
Smarty.
Organization.
Jen?
A 3-year-old that was just,
Can we come back to that, Jen? Thank you very much. I'm sure there's a 3-year-old just inducted. Can we hold that thought? I want to talk about why that doesn't surprise me.
Right.
Believe it or not. It doesn't surprise me because I would almost guarantee there are many 3-year-olds out there that will qualify.
So then
And what I want to do is I want to figure out, what does this mean? What does this mean? If you have to be in the top 2% of IQs, if I have an IQ of 130, does that count? If I have an IQ of 132, is that high enough? See, the question is, it says I have to be in the top 2%, but I don't know what the top 2% is. You see what I'm getting at here, friends? So what I want to know is, what is that IQ? And basically, what is that IQ cutoff? At some point, there is an IQ score that separates the top 2% from the bottom 98%. We have a fancy general name for it. It's the what? Using the word percentile. Go ahead, be brave. It's the 98th percentile, P98, right? It's the 98th percentile. So basically, we have to find the IQ cutoff that is the 98th percentile. If we find that IQ score, we will then know the dividing line. You have to get at least that to be in the top 2%. Anything lower puts you in the bottom 98%.
Mental something associated.
It's not important. I'm sure we can Google it. I don't care that much. But I know it's just called Mensa, and Mensa has this kind of what's the word I'm looking for? Where our sleep is murderous. No, it just has this thing like it's smarty pants people. It's smarty pants. I mean, and this is what I want to do is I want to find out. Let's see how smarty pants you have to be IQ wise to get in. Yeah,
Is it
Jan.
the top 2% of whoever like tries to get in, or is it?
Based on this, friend.
Oh.
Based on this, based on the fact that the average IQ, very good question, based on the fact the average IQ is 100 plus or minus 15, based on that distribution, now let's make sure we can see this, because I want to draw a picture that goes with this next. You can't see that there. So basically, Jada,
From 85 until 115.
here is the entire distribution of IQ scores.
In the world?
By definition, this is a great question. See, what Jada is towing the line between is the idea of a sample and a population. Thank you, sister. Because the tool we're going to start developing at the end of the day today gives us that step to get from a sample to a distribution. So by definition, this is every possible IQ, even those who haven't taken IQ tests.
Okay.
Do they? So that's a great question. It's a little bit fictitious, right? It seems a little bit strange because we have the entire population, but that's how these tests are set up. What we'll see at the end of the day today is that beautiful crossover that says, I don't have the whole population. Oh, by the way, you don't need the whole population. You can get a sample and draw an inference, ooh, that's a great word, about the population from that sample. Thank you, Jada. Great question. I'm going to need about half an hour to answer that one. Maybe like 45 minutes.
Okay.
Great question. We can get to Jen's a lot quicker about the 3-year-old.
Okay.
Okay, here we go. For IQ, friends, what number's in the middle? 100. Okay, that's standard normal. Jada, hold that thought. That's much quicker. That's like 2 minutes. 100. Which percentile is 100? Which percentile is 100? Don't overthink this.
Oh, 100.
Isn't it? It half or below, half or above. It's a purely, I know, it is Wednesday. It's been a week. It's been a week, you guys. I understand. It's understandable. Speed is not the issue. It's just make sure you make the connection. Half the curve is below, half the curve is above. Fantastic. If we go out, say, if we go up to 115 or down to 85, you know where this is headed, don't you?
Yep.
You know where this is headed. That's about 2/3 of your data right there. That's about 2/3 of your, roughly. Which means you got about 1/6 of it out here. Roughly 16% here and 16% here. Ish. I'm ishing. So you got 16% here. So clearly 115 isn't high enough, is it? Clearly 115 isn't high enough because that leaves 16% up top. Let's bump out again. Let's bump out here and bump out here. So now this is going to be up to 130, right? And then down to, now we're into that idiot range, right? See, you all laugh. It's an IQ term. You shouldn't be laughing. It's just like it was called Sam or the Lorax. I mean, it could be called anything, right? It could be called anything, but unfortunately, we have these funny connotations out. Idiot, moron, imbecile, feeble-minded. That was another good one. I don't know if you saw that one or not. Feeble-minded. But they were all levels. Okay, so here we go. Who's out here now?
3%.
Ish, right? Right? Ish. You got 95% in this chunk here, which means you got 2.5 and 2.5 here. So clearly, somewhere out here, somewhere out there is an IQ score that cuts 2% on the top, right? 2% up here, and therefore 98% back here. And our job, of course, is to find that. That's the whole point of this question is, let's find the cutoff. This is 98% right here. So that's our job. Our job is to figure out what that kind of strange command, get in the top 2% of IQ scores, is. Yes. Now, the problem is, I didn't give you a program to do that. Is this a forwards or a backwards problem? Have I mentioned that already? This is definitely backwards. I mentioned it was backwards. Why is it backwards? Do you remember the difference between forwards and backwards from, and this has been a week, so it might be tricky.
Because you're giving us a scale.
Because I'm giving you what?
The percentage.
Yes! And I'm asking you for the value along the horizontal scale. That makes it, again, my definition, that's when I set the program up, that's what I called it, a backwards problem. A forwards problem was like the one we did in class. I gave you the numbers on the scale, and you told me the percentages that were above them. Here I'm going backwards because basically I'm giving you the y value, you're giving me the x value. Is that fair?
Yeah.
But you can't use the normal right now because that's not the normal curve. That isn't the standard normal curve. We have to do just like that vomit-inducing image had. We have to compare, and Jada, this is what you were talking about. We have to compare this to the normal curve, which has what in the middle of it?
0.
That's got 0 in the middle of it. That's got 0 in the middle of it. But logically, we still have to approach it the same way. We have to find the cutoff score. It's going to get in the way. We have to find a cutoff score over here, and I don't know what it is, but I do know it's a z. I know it's a z because that's the standard normal curve is the z curve, for whatever reason. And somewhere, there is a z that cuts off the top 2%. Somewhere there is a z that cuts off the top 2%, which also cuts off the bottom 98%.
Yeah.
So here's the sequence of events. We're going to find that z, and then we're going to convert it to this IQ score. Because once we know that, we've already got these two wonderful pieces of information here. We can use all three of those together to get us onto this curve over here. So that's those arrows going back and forth on that vomit-inducing graph. The arrows show us how to go from one to the other. Fair enough? Ish? Okay, let's do it. Now we're on the standard normal curve. Can you guys find this z right here? Can you give me a hell yeah? Well, okay, we'll take that. Yeah, you can. You can because it's a backwards problem. Let's pull this down so you can see. Oh, goodness. Okay, fire this up. All right, we're turned on. We got to go. Oh, yes, that was beautiful from 105. So we're going to program. It's the normal. Backwards. Which way do you want to shade? Because you can pick either right now, can't you? You can either pick shading to the left or shading to the right. The difference is in what percentage you're shading. If you go left, you'll shade 98%. If you shade right, you'll shade 2%. But they'll both give you the same answer because the same z-score does that. So your guys' call. What are we doing?
Left.
Left it is. We're shading to the left, and we're going to shade 0.98. 98%. Enter. Here it comes. It's going to show you the shade to make sure you shaded it correctly. Yes, there we go. Almost all the way out. Boom. There's your z-score. 2.05. Makes sense. I think it was David that said when we've got two standard deviations, we track roughly 95%, which is not 96%. 96% would pop us out enough to put 2 and 2 on the tops and the bottoms. So we had to go a little bit further, 2.05. Put this in your mind now for 244. That is a standard deviation measure. We have to go out 2.05 standard deviations. We spoke of this last week, but that was last week, it was a long time ago. Those measures along this curve are standard deviation markers, much like they were over on that curve. It's just now they're standardized standard deviation markers. 1 means 1 standard deviation. 2 means 2 standard deviations. 2.05 means 2.05 standard deviations. You can have any number that you want in there. So we now are done with the normal. That was all we needed them for. That's all we needed them for, was to figure out that this z right here was 2.05 standard deviations. The problem is that doesn't tell me an IQ score. That just tells me in order to get into Mensa, you've got to be 2.05 standard deviations above normal. We have to turn that into a meaningful value. So what does that mean, 2.05 standard deviations above normal? What do you think, Jada? Go ahead, be brave, be brave. You're looking in the right place. She's looking up there in that top left corner. Go ahead, go for it, my friend.
So 15 plus 15 plus...
Plus 0.05 to 15. Very good. See what she's doing. What that means is you've got to be 2.05 standard deviations above normal. So what she said is, so take 2.05, multiply it by 15, and add that to the average, because that will put you, right? Here's normal, 100. You've got to be 2.05 standard deviations above. So all you've got to do to figure out what this question mark is take the average, 100, and add to it 2.05 of the standard deviations. So if I'm doing this correctly, I'm getting 130.75 or roughly 131.
No, that's perfect.
Is that 1.75 with this one?
Yeah.
Let's just call it 131 to round it off to a whole number. Is that okay? So you're going to have to get, and you have to have an IQ score of at least 131 in order to test into Mensa. 130 won't do it. 130 doesn't get you far enough because 130.75 is the actual literal cutoff, but assuming they go to the nearest whole number. So 130 won't do it, 125 won't do it, both of which are very, very high IQs, but they won't get you into Mensa. 140 will, 145 will, and things like that will. But 131, that's your cutoff right there, friends. That's the cutoff for inclusion into Mensa. That's the cutoff between the top two and bottom 98%. Is that fair? Do you realize you just used the formula from Wednesday? You did, didn't you? You're looking at from Wednesday. Let's put them over here on the side. From Wednesday, we'll make a little laundry list here to keep track. There's a forwards and a backwards formula. There's a forwards and a backwards formula. The forwards formula is this. Z equals X minus mu over sigma. That's sigma. Let's make it like a sigma. There we go. That's the forwards one. We used that on Wednesday of last week. We'll use it again in about 2 minutes. Okay? The backwards one is the one that we just used, although you might not have realized that you used it. X equals mu plus Z times sigma. And that's what you just did, without even realizing you were using it. You took the average, and you added the number of standard deviations applied to the standard deviation from that particular population. Boom! Yes. Now, on the in-class exam in 2 weeks, I'll put these on the board for you. Don't memorize them, please. You'll have them in your head by then anyway, but don't memorize them, please. Please, don't memorize them. Got them right there for me. Cool? Yeah. So essentially, what made this a backwards problem, well, let's back up. What makes it a normal distribution problem is the fact that you will be told the data is normally distributed. That's what's kind of nice about it. You will be told the data is normally distributed. I mean, it has to be given to you in that respect. You can't just assume something's a bell curve. Lots of things are, but some things aren't, as you saw from that image. So I'll tell you, normally distributed, and then you'll get the average and a standard deviation given to you. Then once you have that, you have to establish, okay, is this a forwards or is this a backwards problem? And that's kind of the point of the next 20 minutes is to figure this out. Now, Jen's comment was awesome. A 3-year-old recently got inducted into Mensa. This doesn't surprise me as to why that happened. What does 131 IQ mean again, in terms of context? Right. Remember what IQ stands for? Intelligence quotient. Intelligence quotient. What's it a quotient of? It's okay if you don't remember. Mental age and physical age. Mental age and chronological age. So if a 3-year-old has an IQ of 130, I'm going to solve a little equation for you here real quick. That's an IQ of 130 as a decimal, because it's easier to deal with. 3 years old, chronological age. Mental age would have to be 3.9 or roughly 4. So they'd have to have a mental age of about 4. Now think about that. Have you ever met a precocious 3-year-old that seems like they're as smart as a 4-year-old? Boom! They've got an IQ of 130, assuming that they test like a 4-year-old. That's what that means. So it doesn't surprise me at all that a 3-year-old became a member of Mensa. What surprises me is there aren't more of them. But that just means that their parents aren't putting them through the rigors of taking an IQ test at age 3, which, good. Seriously, let them catch frogs like my son does all day. Look for turtles. David, what's on your mind, my friend?
I was just wondering if they're 3, wouldn't they have to test 130% higher than everything?
No, it's 30% higher.
30%.
The 1 represents they're just as smart as they are old.
Okay.
The 0.3 is the 30% higher, and 30% above 3 is roughly 4-ish. I'm rounding, it's 3.9, but rounding it up to 4, that means they tested as a 4. Jen, does that make sense?
Yeah, well, when I was reading the article, it was saying that, like, when younger kids are, so I guess 2 was the youngest anyone's ever been.
Tested as an IQ? What was that kid's IQ? 150?
Probably.
Mm-hmm. Off the chart, probably.
But it was saying, like, they have to, like, retest them every year for them to continue staying in Mensa, which is the thing why a lot of kids aren't inducted because parents just don't care. It's like, well, a year from now, they could go back up to their normal IQ level.
And the biggest question I have is, what do you do with the results once you have them? I mean, suppose a kid has an IQ of 160 when he's 2. What does that mean? I don't know if it means anything. It's an intelligence test. I don't know what the hell intelligence is. except that dolphins apparently have a lot of it, and little white-footed mice apparently do too. That's what I know. I don't know what it actually implies. It isn't like financial or emotional wealth or something like that. It's a strange idea that somehow this test tests. But this right here tells me why I'm surprised more 3-year-olds aren't testing in Mensa, or at least, I mean, there probably are many, many more IQ, or kids at very young ages that would be top 2%, top 1%, top half of 1% even, for that matter. That doesn't surprise me at all. I mean, I know my friend Drew met my son Max. Max is 5.5, and he was just chatting. She's like, my God, he seems like a little 8-year-old kid. Just because we're always talking to them. But is that intelligence? Or is that knowledge? Right? I think he's too young to have wisdom. You have to be burned a few times to get that, right? But is knowledge, information, intelligence, what are these things? I don't have an answer for you. I don't have an answer. All I know is, because of that, we can run some numbers in play. And because of that, the definition of what IQ is, we can address Jen's question. So thank you. Quite nice. Fair enough? Yeah? Let's do another forwards and backwards problem and make sure you guys have that locked down. Then we're going to roll some dice, and we're going to address Jada's question after the break, for sure. Because that is a very, very good question as to, doesn't it seem a little fictitious that we have the entire population? Yes. Because in reality, you don't get the entire population. You get a subset of it, called a sample. But when you collect enough data, you can essentially assume you've seen the whole population. Like this next example. This is one of my favorite data sets. Human pregnancy. Here we go. Blank screen. Here we go. So here we go. So that top bit is kind of what you have to be seeing to understand that you're dealing with a normal distribution. Can you see that? Not so much. Let's make sure you can see this. Tilt this back for a sec so those playing the home game can read it. All right. The dead giveaway that you are dealing with normal distribution is line 3, where it says you are. And really, friends, you have to be told that. There is no way, if you look at that paragraph and take the words normal distribution out of it, that you can apply the methods of what we're doing right now. The only reason what we're doing right now is the fact that it's bell-shaped. So, approximately normal, 266-day average, plus or minus 16 days. Let's talk about preemie births first. The definition of a preemie birth. Now, this is one of a few that I've read, but this is my favorite. The 5th percentile are the preemie births. Good, Trevor. I love it. Furrowed brow up there. Very nice, my friend. Tell me why the brow is furrowed. Why is the brow furrowed, my friend?
What is 5%?
Nice! That's the, oh my God, there's an echo in that hallway. That's the question. If you tell an expectant mother, your birth might be a preemie because you're showing the signs of an early childbirth. Oh my God, what is that? Well, it's 5th percentile. That doesn't answer the question. That says what the preemie births are defined to be. It's kind of like saying if you're in the top 2% of IQs, you can get into Mensa. But it doesn't tell you what your IQ has to be. It tells you have to be the top 2%. This tells you have to be in the bottom 5%, but what doesn't it tell you? What doesn't it tell you? Right. What that day length, what the number of days is. So, what do you think, friends? Forward or backward problem? Forward or backwards problem? Most definitely a backwards problem, huh?
Yeah, because we have percentage.
Because we're giving you a percentage. And generally, the backwards problems at the early stage of the game cause the furrowed brows like Trev's, which is great. I mean, very often. You're like, wait a minute, I don't see anything up there. Actually, you see everything you need to see up there. Everything you need to see is right there and right there. That's all. As soon as you know it's normally distributed, you know where the bottom 5%, well, via technology and or tables and or calculus, you can figure out where that spot is. Shall we? Yes, let's go over here. Slide to the sideboard. We'll use this board over here. Okay, so this is preemie births. We'll do preemies, and then we'll take a break. We'll come back and do induced labor, which is the other funny one to kind of think about. So preemie births. Now we know that the average length of pregnancy, according to this data, is 266 days. Now, Jada, back to your awesome point, which we are getting to. I promise we're getting to the break. The reason we're calling that mu and not x bar is because so many births have been witnessed, measured, and timed, if you will, from assumed day 0 to birth. That's the accepted average length of a pregnancy. Now, I've seen it fluctuate a couple days either way.
Yeah.
Sometimes it's 270, sometimes it's 260. Regardless, we've seen so many births, we're essentially calling it mu. Is that fair?
Yeah.
But this is only in cases when you've seen many. This is why they can also say like the average height of a 2-year-old child is, 32 inches. Because you've seen so many 2-year-old children, you're essentially calling it mu. More on that in 244, and actually more on that in about 45 minutes as well. Plus or minus 16, which is wide. That's wide. That's like 2+ weeks, right? That's wide. So, if we draw a quick curve, and the TI will draw this for us, this is the birth, or this is the human gestation curve. 266 is in the middle. And we know if we go out 16 days,